Uh, okay, everyone, welcome to the forensics of RSCs. My name is LAZAR NIKOLOV. I actually have a slide for that. Hold on. I did some research on RSCs, and despite the hype and the mixed feelings that I've seen some folks you know s- um, say on Twitter, I actually digged in, and I think it is a really exciting technology. So that's why I wanted to take the opportunity and to share this with all of you. And first of all, thank you for Smashing for inviting me to speak about RSCs. Okay, let's begin. My name is Lazar Nikolov. I'm a developer advocate at Sentry with a focus on web performance. I am based in Toronto. I like to learn new things all the time and immediately teach them to the folks in my communities. If you want to find me on Twitter, my handle is at Nikolov Lazar. If you don't think of a question now, but think of a question tomorrow, because this is going to be quite a handful presentation, feel free to tag me on Twitter. Okay, let's dig in. What are RSCs? RSCs stand for React Server Components. And they're this new architecture, new technology in the React ecosystem that leverages the good parts of CSR and SSR. And it also minimizes the bundle size. What's cool about it is that it also leverages streaming HTML, so the browser can start rendering and drawing pixels before the actual request is finished. And we'll see about that in better detail. Before we dive into RSCs, I think it's important to go through the evolution of how we rendered React applications throughout the times. So at the beginning, on day one, the first React application was rendered using CSR, which stands for client-side rendering, which means we basically wrote all of the JavaScript for our application, bundled the whole thing, put it on a CDN or a server, and then just threw it at the browser, hoping that the browser knows how to handle it. And the browsers did. They did know how to handle it, but we had some issues. First of all, we shipped a blank HTML tag, which was not good for SEO, right? And then the JavaScript bundle was way too big, so we needed to do something about that. And in order to fix all of those things, we started rendering our applications on the server. And lo and behold, SSR, server-side rendering. This was the way web applications and websites were rendered, even back in the early 90s or like early 2000s. But yeah, we're going back to fix things. So we're doing SSR now, but we actually need a server now, right? We need a server to render our pages, to render the HTML before it gets sent to the browser. So apps are more expensive, CDNs are cheaper. We need servers to do that for us. And there's one thing, but the other thing is we keep spending time rendering the HTML for the header, for the footer, for the navigation bar, or for the app shell, but it never changes, right? We need to do something about that. So we branched into two more rendering strategies, SSG and ISR. SSG is static site generated, and it's basically SSR, but we're not rendering on the server, we're rendering at build time. We're grabbing the output and we're serving that on the CDN, right? So we're back on the CDN now. Things get cheaper. The time to first byte, which we ruined in a way using SSR, is actually very fast now, because we have all the HTML already generated for us. So the CDN just serves that. And the bad thing is that if we want to change anything, or like any of the content on the website, we have to rebuild the whole website again. And we're talking about, again, rebuilding the header, rebuilding the footer, rebuilding the page shell, but it never actually changes. Only one blog post got published, for example. And why do we need to go through all of those things? So we came up with ISR. And I mean we as like the front-end full-stack community, not as in Sentry. ISR is actually invented by Vercel in their next, I'm not sure which version it was, but yeah, ISR stands for Incremental Static Regeneration, and it's basically like SSG, but you do need a server now, But instead of rebuilding all of the components, like the whole website, you're actually rebuilding only a small part of the website, which makes things a little bit easier. But as you see, up until this point, we juggled between client-side rendering and server-side rendering and static-side generation and ISR, and that only resulted in trade-offs. So in order to fix something, we had to break something else, right? There were always trade-offs. And I think RSCs is the next logical step in this progression, right? How RSCs come into play is that they allow us to choose the rendering strategy on a component level, right? So we're gonna see that. It's really cool. It reduces the amount of JavaScript that gets shipped to the client, and also improves the SEO, which were issues of client-side rendering. But it still allows us to maintain the interactive dynamism that the users expect, which was the issue of, for example, SSG, right? So RSCs have been stable for 1 year, and I think this is the point where most of the people will start to seriously look into implementing RSCs. And at times like this, having a monitoring enabled in your application is invaluable. So Sentry can offer you performance monitoring and error tracking to all of the production instances of your app. So you know how your app performs, especially in times like this when we are migrating to a new architecture. It tells you how your releases are performing and how stable they are before, during, and after your refactoring. So you'll actually see whether you made a good decision refactoring to RSCs, or maybe it wasn't for your app. And also, you can implement custom metrics like the ones that Terry O'Shea mentioned in her talk before me. If you want to check out Sentry, you can go to sentry.io/for/Next.js. If you want to see it for Next.js or /Remix, if you're working with Remix, or /React if you just want to see React, or /Angular if you're into Angular, etc. There's support for pretty much all the popular platforms out there and frameworks. Okay, let's get into the anatomies of RSCs. This is where it gets interesting. So RSCs introduce two new component types in React. And those are client components and server components. And the difference is not functional. The difference is where they get executed, what gets sent to the browser, and what has access to what, basically. So for example, client components, they're nothing new. Okay, these are the good old components that we know since day one. But we needed a new name in order to distinguish them from the server components, right? And as we know, their code gets shipped to the browser. So that means they get executed in the browser. So it means that they have access to the browser APIs, which means they can handle interactions. And if they handle interactions, what happens? We need to hydrate them, so they get hydrated, right? And yeah, by default, all of the components are server components, so we need to mark these with a use client directive, which is at the top of the file. So nothing new about this. These are the components that we know. Then we get into server components, and these are not marked at the top. We don't do use server for them because it's for a different thing. It's server actions, but yeah, they get executed exclusively on the server. Okay, and they also get executed in one go, in one pass, which helps us avoid fetch waterfalls, which is a situation that we usually had in client-side rendered applications. Because they get executed explicitly and exclusively on the server, their code does not get shipped to the client. Only the output does. Only the HTML gets shipped to the browser, okay? And what does that mean? That means that there is no JavaScript reaching the browsers. That means they can't handle interactions unless it's like HTML native interactions, right? No interactions means no hydration, which is good in this case because we don't want to hydrate static components, right? If only the output gets sent to the browser, it means that it's safe to use server technologies like, as you can see here, await db.product.findMany. This is a Prisma. This is Prisma tapping into the products table finding all the products. And this is okay because this function will just return an HTML with all the products, but not the database connection itself. And the coolest thing about it is that the large dependencies that you bring into these components won't actually contribute to the bundle size because, again, only the HTML gets sent to the browser. So you can bring in all of the Lodash functions. It's not going to change anything. Okay, that is what's cool about it. And these two components have their own interesting relationship. So I mentioned that by default, server components are the default type of component. And if we have a client component, we need to explicitly mark it, right? That is what the React team wants us to do. By default, build everything as a server component. But if we need to handle a user interaction, like an on-click listener or drag or mouse pointer, or if we need access to the browser APIs, like the local storage or cookies, etc., we're going to convert that component into a client component. But everything else stays as a server component. And one thing that you need to know in this case is that client components cannot import server components. Okay, that's because the way that the website is rendered, client components handle user interaction. That means they re-render a lot more often than server components, right? And when they re-render, how do we re-render the server components? We can't just send the code back to the client because we'll leak all of the stuff that we want to keep away from the browser. That means it's not possible, and it's not impossible. Okay, you can pass server components into client components through the children prop. You can do that, and that's fine. But you can't explicitly import server component from server component JS. You can't explicitly import them. For example, the compiler is not going to yell at you if you do. But bear in mind that if you do import a server component into a client component, it'll get converted into a server component. So two things can happen. If you have a db dot something, if you're using a server technology that does not exist in the browser, it's just going to fail. But it also means that any like API keys or anything that you're using in that component will be leaked to the browser, will be sent to the browser. So it'll be disastrous, right? React is not going to prevent you. It'll just convert the server component into a client component, and you don't want that. Okay? So that was the relationship. Now let's look at the rendering lifecycle of an RSC's page. This might be a little too tiny for you, but I'm gonna go through and like talk through the whole step. And this is gonna be through the lens of Next.js. First and foremost, when we deploy the Next.js application that uses RSCs, it's going to do one pass of the components, and it's going to pre-render the static server components, and I'm gonna mention them again later, just so you know. But let's say the website is deployed, a user lands on the page, it hits the, I don't know, the slash, for example, URL, and what happens then is the Next.js instance on the server will find that route's server component and ask React on the server to render the whole component tree, starting from that server component, right? So React goes through the component tree, component by component, and what it does, if it encounters a static server component, it'll do another pass, but it already has the HTML, like we mentioned prior to deploying the application. It's gonna see that it's a static server component, so it's just gonna return the HTML. Then if it encounters a client component, these get pre-rendered, so it's going to render the HTML for the client component, but it's also going to generate client component instructions in the form of an RSC's payload, which will get sent to the browser. And these instructions are basically the server telling the browser, here's how you can load and hydrate this client component. Okay, we're going to look at that later as well. But just have in mind that there are instructions on how to load client components. And then lastly, if React stumbles upon a suspended server component, the one that you saw fetching data from the database, it could take a while. We usually wrap those with a suspense boundary, but then we also provide a fallback value, right? What React is going to do is it's going to return the fallback element, which is either a skeleton or a little spinner, and move on to the rest of the component tree. But in the meantime, it will trigger the suspended server component in the background, okay? And then it moves on to the rest of the tree, and then at the end we have a whole bunch of HTML and a whole bunch of RSCs payload, right? So that is the initial pass. What Next.js then is going to do is going to get the initial HTML, it's going to get the RSCs payload, and it is going to stream them to the browser. Okay, and the browser is not going to close the connection just yet, and we'll see how that happens. But you remember that all the suspended components were triggered in the background. As they finish loading, their HTML gets generated, their RSCs payload gets also generated, and Next.js will stream both those things as the components finish loading, right? So initially we see the page shell. I would say initially we see the page shell immediately after visiting the website, and the page shell will have a bunch of spinners around where like the dynamic suspended components are, and then we see them one by one getting replaced with their actual content. That is basically how Next.js progressively renders the pages using RSCs. Okay, so this is how the rendering lifecycle happens in Next.js through the lens of Next.js. So let's talk about the RSCs payload. It is a special data format that includes a whole bunch of stuff. It includes references to resources and files that the browser needs to load, and you can see them in the HL payloads, which are also called hints, by the way. And there's, for example, there's a font over here, there's a layout.css, a page.css. Yeah, server-side React or Next.js tells the browser, start pulling these resources ahead of time. Then we also get instructions on how to load certain JS files. For example, certain client components that appear in the as part of the page shell, right? Any modules, React and Next.js themselves, etc. And you can see them with the I payloads right here. And then we have the rendered HTML, client component placeholders where they need to be injected and also hydrated, and also any props passed from server components to the client components. And you can see them in the $ payloads at the bottom. You don't really need to know exactly what RSCs payload function, how they look like and what they mean. But it's always a good idea to be aware, what is that RSCs payload? So that is the RSCs payload. Now I'm going to show you what the browser sees when it visits an RSCs website. And I'm going to zoom in, don't worry. And I hope you can still see it. But basically what I did is I used curl curl, the command, to make a get request to my localhost 3000 and save everything in a chunked-response.txt file so I can, pick at it later. And I also passed the -d, dash, and --row flags, as you can see here, in order to capture the chunks, the way that, streaming happens, and also the headers. So let's dive in. At the top of the file, we have the headers, right? And the most important one in this case is the last one. The transfer-encoding is being set to chunked. That means the server is telling the browser, I'm going to send you some stuff, but do not cut the connection until I tell you so. And when I send you some stuff, start rendering them as you receive them. Okay? That's streaming. Streaming is not being done through WebSockets, which I initially thought that it was WebSockets, but it's not WebSockets. It's actually the same HTTP call that sends the data, but in multiple chunks, right? Each chunk contains the RSC's payload, which tells the browser at what specific time what to do. Load a file, or invoke a specific JavaScript module, or replace this HTML, etc. That is the streaming, okay? Transfer dash encoding is set to chunked, and now we're streaming. Then we see the first chunks appear. Chunks are, you can see them in two lines. The first line is the size, and the second line is the actual content of the chunk. The first chunk contains the page shell. Maybe there's like two chunks if the page shell is like super big or super long. I don't know. I'm not sure about the limits of sizes of the chunks, but in my case, we can see that, you know, or usually it's going to be the first chunk that contains the page shell, right? So the browser receives the page shell, it can start drawing pixels on the screen right away. We're not really waiting on anything, right? It's kind of like static, it's kind of like SSG in a way. And then we can see all of the chunks follow along, like dunder next dot push is how in Next.js chunks appear if you do inspect element and you see for yourself. So we get a whole bunch of chunks. There's a font chunk at the first one. Then we have a CSS chunk. Then we load up a module. Then another. This is part of the module, and there's some HTML as well. So this is how the server tells the browser, do this now, do that now, etc. Right? And also gives all of the hints, so the browser can preload all of the fonts and CSS, etc. But then some seconds later, outlined in this red box right here, we can see like the communication kind of halts up to that red line, and a few seconds pass, and then a couple of more chunks got received. And this is from my demo app, which I'm going to show you how it looks like in Chrome DevTools as well. But like a few seconds later, we can see that we have two more additional chunks. Another dunder next dot push, which contains some a $sign payload, which is HTML, and then an actual HTML element, which is div marked as hidden with a specific ID that contains something inside a paragraph. This is the first suspended component, server component, being sent to the client. Okay, we initially sent like a little loading spinner, but now we have the HTML, so we're sending that to the actual browser. Okay, so that's how we replace the first suspended component. Then we have a few more payloads being sent, another server component or a client component that got lazy loaded. And at the end, we can see that we have the closing of the body and HTML tag at the very bottom, which means, by the way, the whole document is being sent top to bottom, and the browser still can, you know, paint the pixels without receiving the ending, like the closing tag, and we're grateful for that. And then at the end, we can see a 0 and a new line. That is still a chunk, but that is called a zero-based chunk, which indicates that this is the end of the communication, and the browser can actually close the connection it has to the server, right? It's important to note that this is not this way of sending the data from the server to the client is not React specific or Next.js specific. The header itself, transfer encoding, is I think pretty old. Okay, so this is streaming. This is how the server communicates to the browser that I'm going to stream some stuff, and you're going to invoke them however you know, but I'm going to make sure that, you know, in the first few chunks, I'm going to send you the instructions on how to handle receiving and invoking my chunks. And that's where React and Next.js tap in. All of the like dunder next dot push, that's basically how Next.js handles the chunks being streamed to the browser. That's all there is to it, okay? So this is what the browser sees. The document gets sent top to bottom, but at specific times, Next.js sends specific RSCs, RSC payloads to the browser, which tell the browser what to do at that point. And that's how the browser knows how to render the whole website. Now let's look at this from the in a timeline format. I'm going to show you screenshots from Google Chrome developer tools set on the performance tab and measuring hard navigation, a hard reload. So this is still from the same app that we saw this response from. So at the start, we can see this long blue bar, right? That is the main request when we go to the page. And you're going to see throughout this timeline that the main request is not being closed, okay? But still, there are more stuff happening in the meantime. And at first, we can see that there are resources like fonts and CSS being fetched, as you can see from the network pane. At the top, the green one is a font. The purple ones are CSS files. And also the first chunks of HTML are being streamed. And we can see that through the parse HTML span inside of the main panel. Then fast forward a few milliseconds, we can see that a few JS scripts start being loaded, like the Next.js scripts. I also have the Sentry SDK configured, so we can see the Sentry SDK here. But then also we can see a hydration block, and I'm not sure you can actually see this, but yeah, you can try this on your own. But you can see a hydration block happens, and it needs to happen before we actually see something. And this is not a super long hydration block. It's a very simple one. And then we can see all of the we can see the first frames appear, and the LCP, FP, and FCP are being set here, right? I'm not sure you can see this, but this is like a little screenshot of the page. It has a gradient top to bottom, and it has some text at the top. Cool. Then fast forward 5 seconds. Okay, in the meantime, a server component was chunking the numbers, trying to figure out the, getting all the data, etc. But then 5 seconds later, we can see another parse HTML span here. That means the browser received a few more chunks, right? And now it's ready to parse them. And what happens later? It sees a whole block of a lazy loaded client component, right? And what that means, it's lazy loaded. It wasn't part of the initial page shell transaction, so it needs to additionally fetch the lazy loaded client components, JavaScript, and CSS. And you can see that, where's my cursor? You can see that here at the top. Again, the purple one is the CSS, and the yellow one in this case is a JavaScript. This is the actual component, the client components code being fetched in the browser, right? And this was not part of the initial page load. And if it was, it would have been, if it would have loaded slower. But no, we're actually prefetching this. We're actually fetching this a lot later when we actually need it. Okay. And you can also see that the long blue bar, which represented the main request, actually stopped here after the parse HTML span appeared. That means most likely the server sent the zero size chunk. It indicated to the browser that this is it. I'm not sending any more data, right? And the browser cut the connection and also set the DCL event, DOM content loaded, because now we know that there's not going to be more content. Everything is loaded. The DCL is set. The connection is closed. Bear in mind, though, a lot of things depend on the DCL event. Like if you have scripts that are async, if you have scripts whose type is set to module, these things wait for the DCL event to happen so they can start loading. Okay, for example, you might have a video player that is asynchronously loaded. The video player is not going to appear on the website unless everything is sent from the server. And in our case, we saw that takes 5 seconds. So 5 seconds, the users will be staring at a screen where it's supposed to have a video player, but there is no video player. Okay? So even though we're streaming stuff and the browser is able to start painting them way beforehand, it still doesn't give us the right to take it easy on the performance, okay? Because the DCL is the last thing that the browser will set, and then the whole thing starts from DCL on. All the async scripts, all the module scripts, they're gonna start loading after the DCL. Have that in mind, because it wasn't written anywhere. I got reminded from a person working at Google that if the DCL is here, that means all of these scripts will start to load after this point on, and that's like 5 seconds later in my case. Okay, so don't forget that. Then I took the time to refactor the same demo app in App Router and then also in the page router in Next.js. And what that means is what we saw was RSCs, but I refactored it to use the pages router. And that's basically traditional SSR. And I captured the differences in Sentry. The differences are day and night. Look at this. FCP, FP, time to first byte. On traditional SSR, they're all 4+ seconds. But on RSCs, 170 milliseconds. Why? Because in traditional SSR, the yellow blocks that you see here, those are the resources. They start to load 4 seconds later when the browser responds with the request. But in RSCs, they get to load a lot earlier in the process because the browser returned them as part of the initial page load. Okay, so the differences are night and day when it comes to performance. And yeah, no, this might have been a bit more information, so let's do a little recap. RSCs are new architecture. It leverages the good parts, only the good parts of client-side rendering and server-side rendering, and it also implements streaming so that the browser can start painting pixels and fetching resources a lot earlier in the process. It introduced 2 new components, server components and client components, so that we can, pick what gets sent to the browser and what doesn't get sent to the browser. It does have its own challenges. Okay, like we need to rethink how we architect our applications. And for example, the state doesn't live in one single place like we used to live in client side. Now it's in 2 separate places, right? And you can even call that a state if it's on the server, etc., etc. But overall, we can see significant performance improvements in our application. So thank you all. That was my presentation. If you want to check out Sentry, there's a public sandbox on sentry.io/demo/sandbox. You don't have to register. You can just go in and start clicking at things. And of course, if you liked the presentation or if you have a few more questions later, you can follow me on Twitter. My handle is @NIKOLOV. Thank you all.
Wow, that's quite fascinating. Thank you so much. I think I can hear myself as well. It's like maybe an echo coming through now, right?
I think it's me. Yeah. Let's try this.
That's okay.
I'm gonna mute while you're talking.
That's okay. That's okay. It's fascinating. Thank you so much for the wonderful presentation here. I mean, I was quite impressed to see like in such an enormous level, like really cool level of detail on what's happening under the hood. We're a bit running behind the schedule, but I think I just want to bring up one question maybe, and then I'm going to bring the others a bit later. And the question is from Sergey, and wonderful to see here Sergey as well. Sergey is wondering, are there only server component and client components, or are there any CDN edge components versus origin server components?
So for example, in Next.js, there's a case where Next.js can pre-render some of the static server components at build time. And you can, I think if you host on Vercel, you can, Vercel is going to distribute them on a CDN. So they will be served from a CDN, whereas the suspended or dynamic functions, they're calling them, they get actually invoked in either serverless functions or, yeah.
Mm-hmm.
So, yeah.
And then maybe just on top of that, it's also kind of a follow-up question for Sergey. Also, how do you designate static rendered components versus server components?
These are done, for example, in Next.js. These are done automatically in Next.js. So, for example, if you're using any of the request time functionalities like the headers function or the cookies function, they're automatically going to be marked as dynamic functions, but everything else is marked as a static function. But there's one more thing that you can opt out of static pre-rendering by, I think there's like multiple ways. You can export the dynamic const set to like always dynamic or something like that. Yeah, there is a way to manually opt out of caching and pre-rendering so that your component, even though it doesn't use any requests, stuff like headers or cookies, you can still force it to be pre-rendered at request time instead of a build time.
Okay. So we will probably dive in more into this, LAZAR, a little bit later. Well, thank you so much for your wonderful, insightful session. I think that everybody agrees that this was a wonderful and insightful thing to share. Thank you so much for the preparation as well. Clap emoji for LAZAR maybe would be in order, I think. And we're going to go into a short water drinking break for maybe, like I say, just a couple of minutes, maybe 3-5 minutes. 5 minutes, I would say. And then we'll continue with Jody for the last talk of the day on demystifying China web performance. Very excited about that. And then we'll bring everybody back in here for a wonderful session discussing the meaning of life and web performance. Right. Well, thank you so much, LAZAR, for joining us. See you a little bit later. Everyone, short break, water break. We'll come back in just a moment. So don't run too far.